Welcome back, ladies and gentlemen. Today we're going to talk about a real-life example involving fleas to be able to discuss and think about scientific notation. So let's get to it. All right, so we have an example in front of us where we're talking about how much blood does a flea consume in a day. Now, you and I might not care about this, but there's plenty of scientists out there who might actually and do follow this kind of information for various reasons. So let's take their example. And oh man, I hate fleas. Sorry, I can't get over that picture. So I might cover it up here every once in a while because it is actually bugging me. Now, all right, so a dog has 100 female fleas. How much blood does the flea consume per day? I am assuming, because I don't know for sure, that the rate at which it consumes blood is only for the females, and we're only worried about females because they may be the only ones who consume the blood. Maybe the males get it from the females. I don't know. Good question to ask your science teacher. And if they don't know, it's a great question to Google, because now I'm kind of curious, and I'll probably do the same thing after I'm done. With that said, let's figure out how much blood per day a flea is, 100 female fleas are actually going to consume. So we know that 1.4 times 10 to the negative fifth is how much blood a female flea will consume in one day. The problem is that's only for one. We actually know that we are talking about 100 female fleas. So if this is for one, to find out how much 100 would be, we'd actually have to multiply by 100 to get our total consumption. Now, at this point, we are going to go ahead and realize that there is not an easy way right now to be able to turn this 1.4, or to turn this scientific notation or this standard notation into the other. What I mean is, normally if we had a same factor, we could turn this into scientific notation, which would just be 1.0 times 10 squared. These two are the same. So I'll put that there. They are the same. So we could look to our rules, but our rules for multiplying in scientific notation. The problem is we don't have the same factor. And because we don't have the same factor, this isn't going to help us. So what we want to do instead is we want to go ahead and keep that 100, because that's pretty easy to work with. But then I'm going to need to go ahead and take this number here and convert it to standard form. So what I got to remember is I'm going to have to start with a 0 point, because I know I'm going to go to the left, because this number is negative. Now, how many times? Well, I went 5 times, so 1, 2, 3, 4, 5. Now, the thing is, that's where it came from, so I have to look back over here and realize if the decimal came from here, the 4 should be right here, because it was already on the right of the decimal, and my 1 should be here. And I should have 1, 2, 3, 4 zeros. All right. So, as I'm looking at this, what I can also notice is I could turn this into a fraction. That's the same as 14 over 10, 100,000, 10,000, 100,000, 1 million. And I'm going to multiply that by 100, and that 0 cancels that one cancels that. And so it's the same thing as 14 over, what is that, 10,000? Yep, 10,000, which is 0. 1, 2, 3, 1, 2, yeah, 1, 4. All right, and I could go through all that with fractions. So here's one way. Here is another way. If I remember here, I canceled zeros because I multiplied. So again, I can go through and cancel zeros, but basically what's going to happen is if I took this and moved it over, oh, I did have an extra one in there. I knew I was counting wrong. My brain sometimes gets tired, just like yours. So here's a second way. I know I can take this 100 and multiply by 0.0000014, and I'm going to get this 0 cancels that one, this 0 cancels that one, so I'm going to end up with 0.0014, which after I made my correction, because I missed it the first time, is the same thing as multiplying in fractions. So whether I multiply in decimal or I multiply in fractions, I can use the same method for multiplying by tens to be able to cancel out some zeros and get the same answer. I kind of like this one because we were able to convert it directly into decimal, so we keep it in decimal. I don't have to worry about putting it into fraction, taking it back into decimal, doing this, that, blah, blah, blah. So this can be our final answer because it's going to consume about 0.0014 liters, or we could do 1.4, let's see, 1, 2, 3 times 10 to the negative third. Notice something about these two, by the way? We could do this, and we know that there's 1,000 milliliters in a liter. So if you went that far, by the way, you could have just stopped here. That's fine. This is just a conversion. This is 1,000 small, so it's milli, and then 1,000 for liter. We get 1.4 milliliters. So this and these two are the same answer. 0.014 liters or 1.4 milliliters are the same answer. Now go ahead and pause the video and copy what is on your screen into your notebook. Now that you're back, anytime you have to rewatch the video for clarity or to remember something, you need to write down what you picked up into your notes. Use arrows, circles, shapes, pictures, whatever else you need to, but add it to your notes to make them yours. Last, ladies and gentlemen, when we are learning, it's about understanding the process, not about finding an answer. We'll see you tomorrow.